All right, in this video, we're going to solve a few log problems and also talk about how to find the domain of a log function. All right, so last time we were evaluating logarithms where I guess if you had an x, it was by itself over here. Now we have a problem where the x is inside here, what we're taking the log of, and then another one where x is my base of my log. And whenever you encounter a log problem, if anybody ever asks me, my standard response is, I have it back here, if you get stuck on a log problem, write it in exponential form. Remember that logs come from exponential equations, so you can always rewrite it in a different way. So for this first one, to write it in exponential form, it's the base. This was my power, so I have 16 to the negative 3/2 power equals what I'm taking the log of. Okay, so I actually have solved it for x just by putting it in an exponential form. Probably I would add to my directions, simplify your answer if possible. So remember that 16 to the negative 3/2, I'm going to put x on this side, is the same thing as 1 over 16 to the 3/2. And with fractional exponents, if you recall, the bottom number tells me I'm taking the square root of 16. The numerator tells me I'm going to cube that answer. So my final answer would be the square root of 16 is 4. 4 cubed is 64. So it would be 1 over 64. Okay. The next problem here, log base x of 8 equals 3/4. I'm stuck on this, so what I'm going to do is write it in exponential form. Same strategy. This time, however, it's going to look like this. X to the 3/4 equals 8. So I have to solve this for x. I have to unlock this. And the way you want to proceed from here, this is the way I think about this. Let me doodle down here a little bit. How do you solve an equation like x to the, let's say you did x to the 3rd was equal to 27. Most people would say, oh, you just take the cube root, right? Which works. You take the cube root of both sides. But taking the cube root is the equivalent to doing what? It's like raising it to the 1/3 power. And why is that good? Because by the the rules for exponents here, the left side is just going to be x to the 1st. And of course, 27 to the 1/3 is really the cube root of 27, which is 3. What I wanted you to see here is anytime you're trying to solve an equation that's x to some power, if it's kind of weird like x to the 3/4, what you should be thinking about is what power would you raise both sides to just get x to the 1st, because that's always what we're trying to solve for, right? If we're trying to solve for x, we want x to the 1st. For this situation, hopefully you see that the power I'd want to raise it to would be to the 4/3 power, the reciprocal. 3/4 times 4/3 just gives me x to the 1st. And then kind of like what we did here, 8 to the 4/3, the bottom number tells me I'm going to take the cube root of 8. The numerator tells me I'm going to raise that to the 4th power. Cube root of 8 is 2 to the 4th. My answer here would be 16. What happens if you have, okay, a log within a log? Well, you can still use the same strategy, write it in exponential form. The trick is, though, I mean, this is, you got to start on the outside, right? This is the natural log of the log of x equals 2. So I want to put the exponential form for this outside log. Remember that it's base e. So the exponential form is e squared equals what's inside. E squared equals the log of x. Well, that was nice, but I still have a log here, and I need to get x by itself, and I'm stuck on a log problem, so guess what? I'm going to do it again. Now my invisible base for log of x is 10. The exponential form says the base to this power equals x. So I'd have 10 raised to the e squared is equal to x. And I guess part of what we're doing here is getting comfortable leaving that as an answer. Yes, e is 2.7-ish. There's lots of decimal places, but you can literally just leave it as e. It's better if you leave it as e. So 10 to the e squared is totally fine as an answer. If you want to know what that is as a decimal, you can punch it into your calculator to get you an answer, but this is totally fine. Okay, as promised, just like with other functions, you should have probably done some domain questions for other functions. We can answer domain questions for logs, remembering that, what do we know about if I've got log base b of anything, stuff? What we discussed on a previous video was whatever you're taking the log of, which I'm calling stuff, cannot be 0 and it cannot be a negative number, which is basically saying whatever you're taking the log of has to be greater than 0. This is going to be our how we're going to tackle a log domain for this first one, f of x equals log base 2 of x squared minus 25. What I'm taking the log of is x squared minus 25. So if I'm trying to figure out what numbers would work, I need to make sure that x squared minus 25 is greater than 0. Okay, word of caution here. You remember, with inequalities, you don't necessarily always want to solve them the same way as you would an equation. If this was x squared minus 25 equals 0, yes, I absolutely would move the 25 over and take plus or minus the square root to get my two answers. But if you try to do that here, if you try to move the 25 over and get x squared is greater than 25, first of all, there's a little bit of weirdness, because if you do plus or minus, you get x is greater than plus or minus 5. But what does that mean, right? If x is greater than plus or minus 5, what are we talking about? Are we talking about only these numbers? These numbers? What are we talking about here, right? Let's come back to this, because this is actually not going to work for you. You're going to get the wrong answer here. Remember that if you have an inequality, if this factors, you always want to choose that root. This factors into x plus 5 times x minus 5 greater than 0. You should have done some of these types of inequalities previous to this video here. Remember, when you have multiple factors and you're trying to find when it's greater than 0 or less than 0, this is when you want to use the number line technique. We have -5, +5 as our key numbers, and we pick some test numbers. So something less than -5, maybe -7, something between -5 and 5, maybe 0. Maybe here I use +7, and we're just testing these to plug in and see what kind of a number will we get if we plug the -7 into this expression. -7 plus 5 is negative. -7 minus 5 is negative, but a negative times a negative actually gives me a positive number, which is what I want, right? Greater than 0 means positive. So I know that these numbers are going to be part of my solution. And already you can see, right, if we tried to do it by taking the square root, that did not appear to be part of my answer, did it? It did not appear that I would want numbers less than -5, which is why you definitely don't want to do it that way. If I plug in 0, 0 plus 5 is positive, 0 minus 5 is negative. Positive times a negative is a negative. We don't want that. And if I plug in 7, both of these will turn out to be positive numbers. So this is positive, and that means I want these numbers as well. So in interval notation, my domain is our numbers from -infinity to -5, parentheses, or parentheses 5 to infinity. One more, just a little bit different here. We know we can't take the log of a negative number or 0, but I have 2 logs here, right? So I have to address both of them. This outside log, what is my stuff? What am I taking the log of? I'm taking the log of this, right? So one thing that has to be true is 1 minus the log of x has to be greater than 0. But what also has to be true is this log right here. What am I taking the log of for that one? I'm just taking the log of x. So it also has to be true that x has to be greater than 0. If I move this over, or let's subtract 1, and then if you multiply by a negative number, both sides, remember that that changes the sign. So this would be the same as log of x is less than 1. Okay, and you can put this in log form. This does work for an inequality. Remember, your base is 10, so this is saying 10 to, but when you do it, it's 10 to the first is over here, right? 10 to the first. And that kind of leaves the x there. So this is saying x is less than 10 to the first, which is just 10. My domain has to satisfy both of these. So what are the numbers on the number line that are both less than 10 and greater than 0? We're talking about these numbers here. So in interval notation, my domain would be parentheses 0 to 10. These are the numbers that I can plug in, not including the 0, right? Plug in to x and not worry about taking the log of a negative number or 0. All right.